because empathy, because measurement that we have relies on user perception and subjective assessment. So therefore, what we want to do is to have some automated computational method that to somehow provide that objective assessment. So in order to do that, we need to be able to model or simulate empathy. So how to do that? Well, currently, we are not able to recreate the human neural cognitive system in machine. So therefore, what we want to do is to provide the certain level of simulation of human-like behavior. And those, we have example of those in socially assistive robotics. So therefore, what we want to do, we want to be able to provide some computational model that we're able to monitor, let's say, or represent user emotional state, and through that react with some predefined expressions that are perceived as empathy. So therefore, a user can then perceive those reaction as demonstrations of empathy. So what can we have in terms of a computational model? Well, we can use emotion contagion. In other words, we can provide or mimic facial expression. In other words, we mimic emotion. We can have an avatar as a representation of XR system or some other construct to try to mimic that and provide emotions. We can then look at the some other approaches, let's say, model emotional space to look at the pleasure, arousal, and dominance, and therefore try to provide empathy mechanism, empathy modulation, and expression of empathy. And also another approach is perhaps some formal language-based model, and so on. We can even move it even forward and to think about perhaps empathic reactions between syntactic characters and see, well, if we have two NPC, non-player characters or non-user characters in the XR, are we able to actually replicate or demonstrate emergent empathic reaction between those characters? That also leads to the user and context modeling. In other words, in that user and context modeling, we need to learn the context of human empathic behavior patterns. With that, we can then, let's say, collect or monitor behavior of an avatar that's manipulated by a human acting in an empathic manner, and then see how that work and with user and try to train and develop models that can be then used to reproduce those virtual agent behaviors in response to certain user emotional states. So then that leads us to adaptive XR, in other words, real-time physiological and psychophysiological data and user profile information that also provides with ability to adapt certain content element in that virtual world, not just synthetic characters or avatar, but maybe even some characteristic of the surrounding virtual environment, from very simple lighting to tone of voice or stress level in the voice or audio feedback and so on. And in order to do that, we need to use machine learning and other AI techniques. Plus, as observation about that, again, empathy is a complex concept, and in order to be able to effectively use that for empathetic machine, we are lacking data. So therefore, we want to be able to collect a large amount of data, and that's certainly something that will need to be done. And once we have that data, we can use various learning algorithm and replace some manual labeling or describing, what is the emotion state of user, or what that emotion could be, can be labeled with, replaced with automatic detection. So in other words, we need some unified view for empathy computation and how that empathy computation can then be integrated within XR. Just kind of to relate some personal, not personal, experiences studies. We have conducted studies with adolescents who have autism, and one of the challenges that precisely that to teach them how to label or detect emotion. So in a way, what we can think about XR, although perhaps it is very, not necessarily the best possible comparison, is that we can think about XR as someone who has autism who is not able to recognize emotion, and therefore we are trying to teach that XR system to be able to recognize emotion and act accordingly to produce expected behavior in order to be able to better socialize. So what are some of the open questions following from that? Well, first of all, behavioral cues of empathy, optimal ways to extract useful features from data, how we can manage iterative process, how we can observe the interaction over time, and also how we can provide some computation and domain-specific computational structure and relations. So now let's talk about empathy infrastructure for extended reality. In other words, what is needed to achieve that goal of empathy-enabled XR? So first of all, just a reminder that the major claim about XR is that it can foster empathy and elicits empathetic responses. Second, that now we have there's now large number of portable and foldable biosensors, especially contactless. So what it does mean is that we can actually measure in real time physiological and other signal using XR. So those measurements, such as heart rate or breathing rate or facial expression, electro-dermal activity, etc., they can inform about cognitive emotional state. So now, if we have that real-time data, we can then use it both to evaluate the impact of XR on user and also to adapt XR content based on user state. And that actually expand to any number of smart devices that can leverage or benefit from mood-aware technologies. So therefore, we can, as we mentioned before, we can use various of those techniques. And now, again, the challenge is how to train such multimodal system, how to fuse all that data streams together to provide the desired stimuli. And that gives us this contextualized data, a diagram that illustrates what is going on. So what we have in terms of user, we have a physical world in which user is placed, and then the subject or participant or user that it has body, in other words, that interacts with that physical world, and then mind. So in physical world, we have those contactless sensors that can then measure both environmental signals, that can measure also physiological signal, and perhaps through some other types of interaction through some more traditional user interface, we can also collect cognitive data. So now what we have from all those sensors, we can identify three main streams of data: environmental data, physiological data, cognitive data that now provides our contextualized data based on social context in which the participant is. Obviously, these three streams are merged together in order and can be stored to provide for longitudinal data, but they are immediately used for stimuli creation, and therefore the stimuli is then delivered back to the user and then cycle continues. And again, idea is real-time signals integrated within XR. So how we can provide or integrate that contextualized data? Well, and what are the benefits of that? Well, we can improve quality of experience. We can also, if you think about SIMs, when it comes to remote collaboration, we have spatial, functional, and cognitive SIMs. So therefore, we can try to reduce those SIMs. And at the very least, we should be able to monitor the user emotional state and context, and use it maybe for training, for learning user preferences for the longer term use. One thing that we should also take into account is embodiment. With fully immersive VR, user is isolated from the surrounding physical world. So therefore, we are losing, well, at least we are not, affordances for embodied interaction are reduced, because we are not able to actually see our hands, although again, these days, VR systems are doing a really good job of tracking hands, etc. Again, that's not quite the same as in real world. So therefore, using AR and MR environments could provide sufficient immersion for empathy. That we don't have a fully immersive system, but with sufficient immersion and with embodied interaction, that can actually provide better results. So our task is to identify what are those best practices and how we can leverage embodied cognition. What needs to be said again is that, immersion itself is not sufficient, and therefore it must be complemented by embodiment. Which brings us back to user experience and ambient computing as two ways or two concepts that we have discussed before that can then be put together for design of XR application. And that leads us to smart immersive environments that we can create. We have the synergy of XR and IoT, and we provide a service infrastructure where our XR application can gain data. So here we have ability to actually, especially in MR, to integrate various characters within either real world or virtual world. So challenges and opportunities there means that we need to measure, somehow we need to measure information from neural activities. We then need to provide that information through some service infrastructure. And then once we have access to and use those services, now we need to explore emotional and cognitive aspects by using the service. So therefore we have that bridge between physical and digital world. So there is always the concept of digital twin, but the digital twin now expands not only to, or relates not only to physical world, but also to user's state of mind, and trying to model that. So that's what are the type of services that then we can use? Well, we can use real-time environmental physiological data. That will be one type of services. Then we can contextual data, providing instant to mental state, and also be able to get as a service to get longitudinal data analysis, because that will allow us to identify patterns, perhaps predict behavior, and in different architectural and social contexts. So in other words, with that, we can have that embodied cognition as an interplay between brain, body, and world. Which then leads to various types of interactions, context sensitive, that allow us to manage with that context sensitive interaction. We can manage levels of complexity with little interaction. Although we need to be careful about that if we try to do too much, because there is that sweet spot between not really looking or taking into account context to being really too much context sensitive, which would then be patronizing. So there is a sweet spot in between that is just enough context sensitive while allowing the space for user to change or modify behavior. So that also again brings multiple channels of information from audio, video, and other parts. So what are some of the examples? So one of the studies that we did was with, as I mentioned before, with autism spectrum disorder, that we have a mobile neurotechnology tool. We use mixed reality, and another reason why we use mixed reality is because people with autism usually have that sensory experience sensory overload. So using fully immersive VR headset is not really something that is that they can easily do. And then what we did, we have EEG, wireless EEG headset with empathetic device which collected physiological signal. And so that were what we presented to user, various characters with different facial emotion. And by reading corresponding biometric data, we were able to actually derive certain indication of user recognition of emotion. Again, keep in mind the participants in these studies were people with autism spectrum disorder. But it brings us to another interesting aspect is about neurotechnology, because with neurotechnology, we can really provide, get window into brain activity with using various spatial, temporal, and signal resolution. Obviously, EEG is very affordable, well, to a certain extent, I guess, but depends on the number of electrodes, and it's real time, it has high sampling frequency. But what it means that we are getting information from on the outside of the brain, and therefore we need to kind of decide what is inside, determine what is inside, which is not easy. On the other hand, using fMRI is not only impractical, using magnetic resonance, but also has a temporal resolution that is much larger, therefore every second or so, while sampling for EEGs are like a millisecond, for MRI is second range. So, but that can be put together in certain conditions. We can actually merge fMRI and EEG, conduct some baseline tests, and get that some correlation between EEG signal and corresponding fMRI signal, and help us better predict reactions that are there. Another example is remote sensing of various physiological signals. So an example here is breathing rate. We can use ultra-wideband devices to get breathing rate, which in certain cases can be indication of stress or some other emotional states. So again, multimodal approach, combining things together to get better insight to user state. So the next step here is, again, connecting extended reality and activity in a single framework that will provide us that foundation for empathy infrastructure. And in order to achieve that, we certainly need to work more on standardization to promote and support interoperability. How about multi-user XR experiences? Here we have some, now that we move from single user to multi-user case, obviously we need to face some networking and scalability challenges such as latency and jitter. We also have limited local computational resources, and especially for we opted for using various type of devices, from high-end headset to some perhaps even low-end mobile phones with an AR app. So we also need to take into account what are the different network architectures. And finally, once we have that in place, how can we exchange data, how we can share those informations or states of individual users. So therefore, we can then share those physiological cues, maybe heart rate or temperature, or provide some electro-dermal activity. So if we provide that additional information, that can be empathized by another user. Another example is to sharing point of view, support, gaze and facial expression for the avatar, support for communication, and we also need to keep in mind that such as interface can be symmetric. And just to provide very, very simple example of that, so here is a user moving, so therefore we have full body tracking controlling the avatar. And what we are looking here are some information signal coming from a empathetic device that user is carrying right now. So let me just scroll it a bit back. So here we have blood volume, pressure, galvanic sting resistor, or electro-dermal activity, or temperature in Celsius. So therefore, that kind of information can give us some additional clues or indications about other users' state of mind. Not only that, but it can also serve as a biofeedback and help user to understand, well, obviously, my pressure is going up, or maybe there is something else going on. So now we can then look at that as the larger scale educational setting that we can create an extended reality classroom with that also provides service like that. And so we can see not only that, so this is a simple example, that not only that we can mimic actual physical setup of the classroom, but we can also move furniture by embodied reaction in, let's say, some shared environment by using proper body tracking. We can also augment that, and in the lower right, we have figured that we can have posters being presented or added on a physical space. Okay, so now that we have looked at the empathy infrastructure for extended reality, let's take a look at some of the guidelines that we can have. First of all, you need to start with question, what is your objective in terms of empathy? Are you trying to have your XR as an empathy machine, empathetic entity, or empathy enable, in other words, going in both directions? So when we're talking about empathy machine, now that we know that we are trying to trigger certain or arouse certain empathic response in the user, we need to identify what are the behavioral cues or modalities that we are going to use. Also, we need to develop predictive models for impact on empathy, either from literature, or perhaps in this particular case, we need to do some pilot study and see, given the particular domain application and collection of possible behavioral cues, how those cues work, and therefore from that we can develop predictive model that will tell us if what action or changes in XR will have best chance of arousing or triggering empathy. But also what we then need to do is to identify what are our empathy measurement instruments. In other words, we talked about that before when we talk about XR as empathy machine, how we can measure empathy in users. So again, based on the type of the empathy that we are trying to do cognitive, emotional, or compassionate. We also need to identify measurement and go through the design cycle, empathize, then collect requirements, design, select prototype, test, and through that iterative approach, we can then converge on the predictive model and identify those behavioral cues. If you want to design a empathetic machine, so what we need to do, we need to select first computational user context modeling. I presented some of those before, and then decide how to write that. So another, well, at least initial approach can be just to use a predictive model in reverse. So therefore, you can base XR behavior on a predictive model for certain class of users, and therefore based on what user does and what are the situation in the environment, based on that predictive model, now user will now we can then identify or decide to what level of empathy we want to project back to user. In the collaborative case, now we're dealing not only with the environment or XR itself, but also with other users. We need to provide empathy descriptor that should be presented to other users. So now that we have those design choices, what are some of those design tasks that we have that we can then perform? So first of all, how we can facilitate collaboration through empathy. Obviously, collaboration in a sense between user and XR or between user and XR. Identify the effects of long-term use. So therefore, try, if possible, to conduct user studies that are not limited to maybe one time or 1 week, but maybe span a couple of months. Use non-stereotypical avatars to avoid that kind of preconceived notions. And remember, at the beginning, we talked about what can be done in terms of increasing empathy, and one of those things is to try to be aware of and minimize our own preconceived notions. Also, we need to consider Proteus effect. In other words, if users are selecting some avatar that's different from their actual physical behavior, based on the stereotypes, user may try to behave differently in order to match that that selected avatar. And also, we would like to provide support for emotion regulation. In other words, look at that XR as a way to help user regulate or perhaps even control emotion. What are the barriers that we have for that? Well, first of all, how to access such system and provide that full-blown empathy-enabled XR infrastructure is not something that can be easily accessible or easily created. So therefore, that leads us to affordability of various devices that are included there. Furthermore, we have that lack of interoperability or problem with interoperability, how to, especially multi-user case, how to bring the users together, or in case of multiple sensory devices, how to integrate and fuse them together. And that all is further how should I put it, emphasis more by the lack of infrastructure, because again, think about that as a way to have pervasive infrastructure. So whenever we are using XR, that we will be able to service. Obviously, that's not going to happen anytime soon, but we can certainly develop empathy-enabled infrastructure and the test beds for XR that we can try to build our body of knowledge, how we can use it for as technology gets better and better. So what are some enabling technologies for that? Well, first of all, we need to have flexible and open XR resources. Therefore, access to content, access to, let's say, a number of devices using standards such as OpenXR to make it easier to integrate all together. Be able to use haptic feedback and sensory interfaces, because by providing all senses that we are more likely that we'll be able to trigger or arouse empathy, or also to demonstrate empathy. Being able to have full body motion, sensing representation, gestures, pose, they're all contextual information that are important when we identify emotions. And also artificial intelligence, machine learning techniques are there to help us deal with data that we collect and help us develop models, predictive models or computational model for empathy. Next, let's talk a little bit about empathy-enabled XR applications, or what they provide. Well, here are some of the list of applications or application domain where we can use empathy. So education is one of the obvious choice. History, perspective as a part of education, training, medical training, stress situations, how we can identify that, dealing with, let's say, dealing with patient in general, entertainment, but other professions when there where such feature like empathy enabled application can be very useful. Just to talk about more about education, putting aside COVID-19 and everything that has happened, even without that, I think there are a lot of opportunities for XR, because we would like to provide as good experience to students as possible. In other words, provide them access to, let's say, different sites through XR, provide the ability to do various experiential learning exercises or experiments. So therefore, a K-12 or educator can certainly use extended reality to improve on student engagement, and through that, and especially with using empathy, hopefully there'll be also improvement in learning outcomes. And just to give an idea about the size of the market, that we are looking at multi-billion-dollar industry. We can also, through that empathy, we can also look at that through equity and inclusion, ability to reduce barriers and create opportunities for underserved communities. And also look at that, how to facilitate a connection among distributed communities. And in order for that to be achieved, we certainly need more research in terms of to determine efficacy of VR, especially regarding empathy and bias training. We can also think about, when think about inclusion, how XR can be used with by people with or participants with disabilities, and how we can think about that in the context of empathy. Healthcare is another example where XR and empathy can be of use. We can track user mental state. We can identify various disorders such as dementia or Parkinson's disease, even coronary artery disease, by looking at some sensory data. And again, that's something that can be done outside the XR, but in XR certainly does provide some added dimension. Communication. So when we communicate, let's say, with or use voice recognition software and phone, we kind of think about the devices in anthropomorphic sense. In other words, we think that as of them as some personalities, even without empathy. So people can actually confide in, converse with Siri, interacting with social robots. They have names. Also, what a problem that we have is that younger people, especially now, as one of the negative, one of the consequences of COVID-19 and masks, that those kids, especially in early age, did not have that ability to interact, look at faces, recognize emotions, and learn actually how to detect those emotions. So, which means that they'll have reduced ability to empathize, and XR can certainly be very helpful to that extent to help them train. So, with emotion AI, in other words, be able to develop models, put them in XR, provide visual and audio stimuli that can serve as a way to train is probably not the right word, but certainly help younger people develop emotion recognition skill, and through that also social skills. So at the end, let's look at let's talk about some concluding remarks. So first of all, what are the challenges that we have looked at? So we look at the data. So in order to be able to effectively use or deploy empathy-enabled XR, we need to rely on data. The data is not just real-time data coming from the environment, but it's also longitudinal data. So therefore, the challenge is how we can collect that, how we can generate the data. In other words, how we can provide it structured as an IoT-based space or sensor-enriched space where that data can be collected, generated in terms of sensor will generate that based on measurements from the user, and then collect them. That can be stored in the database. So that database can grow large pretty soon, really fast. And so therefore we have that issue with scale. Who has access to database? Can we actually maintain privacy and security? Because some types of behavior can perhaps be just in general, I mean, you would like, you as an individual certainly wouldn't like somewhere to be a database with your daily activities or your movements, etc. So whether be it in within XR or outside XR. In order to provide of that, we have technology costs. So certainly we have some low commodity VR devices that are in $200 to $300 to $400 range. Mixed reality devices are not quite there yet. They're still $1,000 range. But technology costs is also has to do more actually with collecting data, sensor that collect data, or if you look from that perspective, generate data, and the overall infrastructure for that. We also look at the practicality, how often we can actually deal with that. Let me rephrase it. How often we can actually use that infrastructure or collect data, whether we can actually do it 24/7, probably not. Certainly we are not going to use XR 24/7, that's not the point, but even if it is, let's say, using it for an hour or so, how to organize that and how to best provide solutions for that. In embodied perspective taking, what we want to do is to develop empathy through visual embodiment in avatars. In other words, we want to be able to provide that through consistent body tracking, provide that kind of first-person perspective, provide full information about other user body language, if possible. with that, again, as I mentioned before, we need to keep in mind about Proteus effect. In other words, changing self-identity avatar can change the user behavior. And ethics, supporting empathy is not always ethically desirable because supporting means that you can actually do certain things, or you can trigger certain things, or generate empathy in a way that you want in order to manipulate users. So therefore, we need to be really careful about that. That's also interesting kind of to mention as we look at that opportunities to develop empathy and use it in training, etc. That more and more companies are actually using XR for training, and in a part to develop or to train in terms of expected or behavior, or developing social skills, or recognizing some of the challenges. So going back to that ethics is supporting empathy is not always ethically desirable. We have that challenge of forced empathy. Because we can look at, of course, if it is fiction XR, if we are, that's perfectly fine. But if it is not fiction XR, something that is supposed to be news or education, using forced empathy can be very unethical and manipulative. So therefore, we can look at that empathy machining as manipulation. And through that, we can even impact public debate. So therefore, again, we need to be very careful. And the last kind of point is to look at the future technologies. So we talk about full body tracking, body language, etc. And one argument will be, well, the amount of data for that, just point cloud or etc. That's just not feasible, if for nothing else because of communication limitation. But now with 6G being developed and the target deploys, I believe, in 2028. We already see some of the characteristics that we are going to have millisecond latency. We are going to have terabits of bandwidth. With such communication capabilities, we don't have to worry about latency. We don't have to worry about data size. So therefore, we can use holographic communication. So from that perspective, with that holographic communication, we will be able to fully represent remote user appearance, body language, facial gesture. So therefore, that will become far more powerful in terms of empathy support. Okay, so with that, we have reached the end of this tutorial. So just in summary, empathy-enabled XR can be used in many domains. That empathy-enabled domains, empathy-enabled XR from education, healthcare, visual analytics. Certainly, there is a tremendous growth potential, and hopefully this tutorial give you some insight how to start with that and how to provide or start developing some empathy-enabled applications. So with that, thank you for your attention, and I would just like to acknowledge that this work has been partially supported by Virginia Tech Institute for Creativity, Art, and Technology. And also very briefly at the end, a list of the references. So with that, if you have any questions, please type in the chat or just raise your hand and ask questions.
Well, thank you for this talk. This is a very interesting topic. Will you have your slides available?
Yes, that slides are available. I'm going to post that information on this code, and so therefore, and I'll provide URL for that. So just look at this code and get it.
Thank you.
Okay. There are no questions, and that actually we are already it's already the time limit, I believe.
Yeah, we have to leave.
Okay. So again, thank you everyone. Thank you, Beatrice, for your help, and looking forward to see you at the conference at some other sessions. Take care.
Bye-bye.